So for a little follow-up on this mini lathe, I know that some people out there have probably been waiting to sort of know how it's been going. I've been using it for a few different projects and it's been going pretty good, so that's worked out pretty nicely. One of the things I did notice when I was using it, however, is that this headstock doesn't appear to be aligned properly with the ways. Now, there was some comment saying, you know, did you check it or whatever, and I did check it, but the reality is that I'd taken the headstock off so many times that, you know, I'd managed to get it wrong somewhere along the way. So it's actually not cutting parallel with the ways, and so I'm going to try and fix that. And additionally, at the same time, since I'm going to be pulling it all apart, I'm also going to be looking at swapping out. This was another viewer suggestion, but I'll try it anyway. See if I can reduce the noise. See if I can reduce the noise a little bit by swapping out one of these two gears. So currently they're both metal gears that I've replaced, and it's okay at low speed or in the low gear. It's not too bad, but in high speed it's quite intolerable. Quite honestly, it's nearly unusable. It's so noisy. You know, maybe I'm overstating it, but whatever. So the suggestion was to swap out one of the two gears with the plastic gears and see how that goes. So I'm going to try and do that. I'm not sure which one is the better one to swap out. I think I'll swap the one out with the least amount of play. I know one of these had a lot of play and was really shuddering around and galloping around a bit on the spindles. So we'll see how that goes as well. So we'll get straight into it. I will do a before and after audio capture of the different gears and the different gear ratios, and see how that sounds. And I will show that towards the end of the clip after I finish the work. All right, so let's get into it. So before we get started disassembling this, I'm going to take a reading on how bad this is. I'll take a reading across the front and across the top, and that should tell us how parallel it is to this to the ways. So I think I've got it running. This rod here, by the way, is just something I've got out of an inkjet printer that I've disassembled at some time. So it's just a freebie, and should be pretty solid and pretty strong and pretty straight. So I've got it running somewhat centered there. It's not perfect. It's pretty long, and it is what it is. It's around about 0.1 mil. But anyway, I think you get the idea. It's pretty close. So if we run it along the ways, we should be able to see what sort of distance we're getting. So these are all in 0.1 millimeter increments. One rotation is a millimeter. So let's have a look. Yes, bad, really bad. I think we better fix that. Let's do the top as well and see how bad it is running along the top. Alright, now we're checking along the top here as well. Let's see how we go with that. As you can see again, it's not perfectly true. Oh god, it's not even close to perfectly true. But I don't think it's critical for this little test anyway. Let's leave it on 0 there. Let's just have a look how it runs. So I've got the headstock off here, as you can see, and I was having a bit of an inspection, and I think it all looks pretty good in there overall. And as I said before, it's sort of running not too bad on that low gear, and a lot of that, you know, there's not really any sort of friction or anything going on there, so I think in that sense it's been working quite well. But what I'm going to do is I'm going to swap out this smaller gear here. The large gear is the one that I think was sort of waddling around and causing the most of that original vibration that I wanted to get rid of. And as you will hear, these two gears, the metal and metal gears, make a hell of a racket. So this is what we'll do, is we'll swap this out, and hopefully that'll improve the situation. So I got that in there. You can see I'm using the plastic gear there, and it works pretty well, right? I mean, here, see, spins nice, and on the gear, it's a little bit tight, but actually I like that. It's not like any friction, like it's not having any trouble spinning, but you know, everything is nice and you know, not a lot of play in anything, so I quite like it. Hopefully, I think that's really going to solve the problem with the sound. It looks really good. I was thinking that there was going to be some sort of meshing issue or something like that, but definitely doesn't appear to be the case. So I'll get a little bit of grease on there and see if we get that back together, and then I'll see if I can get this thing to be parallel, the headstock parallel with the waves. Alright, and for a little bit of drama, because you know everyone loves a bit of drama, right? I managed to break this gear changing fork. When I was putting this top grub screw here, I managed to actually split. I don't know if you can see it. But it's actually split right down the center here. So that's pretty bad news. You can see it's sort of chipped there on the top there where the split starts. So in other words, this grub screw can no longer tighten up and lock against that shaft, which is no good. So what I did is I had a little bit of this aluminium, I managed to say it correctly right today, aluminium, very good. None of that aluminum crap here. We have the real aluminium. Here we go. Had this bit of bar on hand, so I bent a bit up and shaped it here. And this is a friction fit. Actually, I managed to do pretty good at bending this. And that will friction fit on there. And I've tapped 2 screws in the top here. And I'll just use a couple of countersunk screws to get that back together. So, I mean, the other option was to remake this piece here, which was going to be a little bit more difficult to do. So I thought this is a good way to do it. It'll work. And yeah, this material, I don't know what it is, some sort of alloy of some sort, but it's quite brittle actually. So I guess it has to be pretty hard because it's rubbing up against those gears. But yeah, easy to over tighten this, and you can see it's pretty thin there. So just be a bit careful when you're tightening that screw if you've got this gear change fork, or you will do what I did and break it. And if you did break it, this is a quick solution to fix it up. Anyway, let me get it on there and I'll show you what it looks like when it's on there. So there you go, that's it there on there. You can see the hole is clear on that side. And obviously when I screwed those screws in, I made sure I didn't screw them too tight, otherwise it would break again. The hole's quite deep actually. I think the screws don't go through all that deep, but yeah, I think it's going to hold it on there. I mean, this is only to hold the piece on there so it doesn't split apart. The main force is these bent ends here, and I think it's going to do the job. I think this grub screw now will function, and we can get it on there. It's not too bad, right? Anyway, if you do manage to break it, this is probably a good solution, I think. There's a quick shot of the fix in place, and you can see everything else is in there as well. Yeah, it looks pretty good. Everything seems to move pretty well. I'm pretty happy with that so far. So I've got myself set back up again here so we can check the error, and it's as it was before. Let's see if I can get this thing to slide with one hand. As we move in, it gets further away, and as we move away it gets closer. So it's bent out this way, right? So I want it to go back this way a little bit. So if that's the case, what I'll do is there's this little V ledge that it sits on. I'll put a piece of packing on this side and a bit of packing on this side, and hopefully that will correct some of that error. What I don't want to do is I don't want it to lift up in height, so it's a little bit of a gamble. So what I'll be doing to use the packing is I've got this copper tape here, so hopefully that'll do the job. Alright, so I've been fiddling around with this headstock for a good half of a day, getting nowhere real fast. Well, that's not true actually, I've gotten somewhere. Originally we were around about 0.7 millimeters off over about 14 centimeters or 140 millimeters. I don't know what that is in inches, sorry guys. But anyway, so 140 against 0.7, would be your triangle that we're talking about. But when we're talking about 0.7, we're really talking about a diameter cut difference across that range of about 1.4 millimeters. That was quite significant. So this is what I've got it to at the minute. I've got it down to around about, yeah, I think the last time I measured it was around about 0.15 millimeters. So from 0.7 to 0.15, and if we double that, we know that we get a diameter difference cut of 0.3 millimeters across 140 millimeters. That's not too bad, but I'm still not happy with it. So I'm going to pop this off once more, and I'll give you a look at what I'm doing in here to try to make the adjustment. To be honest, it's quite shocking just how far off this was. You know, it's ridiculous that this was released from the factory in this way, but you know, I guess if I'm seeing that amount of difference, then you might too. So I definitely suggest doing a test like this to see just how far off it is. Now, I'm sure there's plenty of videos on the internet to cover how to fix this and how to check this, but you know, I don't watch those videos. I don't think it'd be interesting if I just watched a video and just repeated it so you could see me repeating what somebody else did. This is my adventure, and this is what I've discovered. So anyway, I'll continue sharing that with you. So let me give you a look at what I'm doing here to make this adjustment. At first I was just really packing this inside edge here and this outside edge here so that it would hopefully give it a bit of a twist, which is what we need to do. We need to twist it this way. But simply put, that was quite unsuccessful. It just doesn't work that way. I mean, it does work to a little bit of degree, but after a while you start packing these edges and the whole thing just starts to lift up and the angle starts to change and you run out of adjustment. It doesn't twist anymore. In fact, I got it maybe down by around about from 0.7 down to around about 0.4 millimeters, but then after that it didn't matter how much I packed here, it really wasn't changing that much. So really the only thing left to do is to actually file the V. And interesting enough, we have a close look at this V, we can see that actually it looks like it had already been filed. Now I've filed it as well to some degree. So it seems likely that in the factory they actually do file this to some degree to make this adjustment. But it's just shocking how far off it is. So in any case, I'm using various different files, such as this file here, which is nice and long, to give a nice soft angular file to try to bring this edge down a little bit. Now obviously by filing this edge here and obviously filing this opposite edge here, that's going to change the shape of the V, and to some degree that's probably just going to be fine. It'll probably sit back in the right way. And I already noticed that this edge here, or this front edge here, was already floating, so it will sit down a little bit more, but it'll probably take the right position. But obviously there's going to be a point where this sits down completely and then this will just be waddling around in here. So in that case I'll be using the aluminium tape, not the aluminium tape, the copper tape here, to pad out the other sides and actually twist it around. And that's what I've been doing. And as you saw, I got it down to around about 0.15 millimeters. So I'll just file a little bit more off here because I still am not quite on the ball and I really want to make it less than say 0.05 millimeters. That would be nice, which would give a difference of 0.1 millimeters on the diameter across 14 centimeter length. Alright, let's have a look how we did here. Ready? Yeah, I think it's pretty good, right? Yeah, nice. I don't think it's that accurate. I'm sure this meter is a bit dodgy as well, but it's not that dodgy, so I'd say it's probably within the target that I set myself, so I'm pretty happy with that. Let's check across the top here. Yeah, it looks like it's around about, maybe up to about 0.1 of a millimeter, around about 0.05 to 0.1 of a millimeter. But I think that's okay going across the top here. I'm not that sensitive on that. I mean, obviously I prefer it to be perfect, but it's not as critical, in my mind at least, as to the depth of cut, though it will have an effect on some things. So I was just checking the tailstock and seeing how aligned it was as well. And obviously I've tested it when the tailstock wasn't extended, but now I was testing with it extended. You can see this is free spinning here. This is the live center, and it's difficult to see, but I've done a paper check all around here, and amazingly the centering is really good. It's quite accurate all the way around, or at least pretty damn close, that's for sure. So I'm not going to fiddle with that. You know, you can loosen these two screws under here and bash this wedge, I guess, to adjust the position a bit. But I think it's pretty close, and these things wiggle around a bit anyway, so I think I'm not going to risk making it any worse. So yeah, maybe somebody might fiddle with it, but not me. I'm going to leave that be. So after reassembling my mini lathe, I managed to get it running, and probably about 30 seconds after running, the ESC decided to fry itself again. So yeah, I sort of expected it would do that on the occasion. And the good news was that the emergency stop, or the automatic stop, or the stall detect on the mini lathe software worked very well within about half a second, and there wasn't that much smoke, but clearly something is shorted out in the ESC because the power supply keeps shutting down every time the ESC starts up, which is what I've seen before. So I'm back to rebuilding another ESC, and I decided to try to make a single board one, similar to the one that we used in the testing before. And this time I'm going to do something a little bit different for making it. Before I was using the heat gun one by one to add all of these MOSFETs, but this time what I've done is I've added a thin layer of flux to the whole board, and I'm placing all of these components one by one. So there it is, it's all sitting on there. Hopefully it won't float away once I heat it all up. I also had to place around about 6 of those, I think they're 608 surface mount resistors. So let's go get it in the oven and see what happens. Well, I think that went better than expected. Things didn't shift. You can see a couple of these things have sort of floated around here, but I think close enough, right? It's definitely a lot easier than trying to use a heat gun to hit every one of those. So what I originally did is I just, well, basically I had the oven around about 220 for 5 minutes, and I used a bit of foil just to cover it to stop the radiant heat from directly burning the board. And in the last 1 minute I switched it up to about 240 degrees, and that was it. I think I took the cover off. It was smoking a little bit, but I guess that's probably the flux burning off a little bit, but I don't see that it's any worse for the wear. So yeah, I might touch a few points with the soldering iron just to make sure we get good contacts on all those legs, but other than that, yeah, I think it's a good technique, pretty easy to do. It's pretty quick too. I mean, it took me maybe 5 minutes to place all these components on the board, as opposed to a couple of hours trying to use a heat gun and applying each of those MOSFETs one by one. And those fiddly little things like those little resistors which I replaced, you know, that worked out pretty easy as well. You just, yeah, I think they're all in place. They all sort of float back into their right place. So yeah, nice and easy. So I've completed the fixes ESC for the umpteenth time. This time I'm using all of the MOSFETs which have actual proper Fairchild markings on them, so in theory they should be a maker item. And I'm only going to use one board as opposed to using the triple board arrangement that I was using before. Looking at the datasheet, each of these MOSFETs is meant to be able to take about 90 amps, so this should be enough. You know, there's basically 3 active at any one time, so should be enough capability to support that no matter what. And this is also the board that I used in that testing analysis with the replaced IR2101. So this board I know is good as far as the processor board goes, and this is a little bit different, and again only using a single board instead of triple board, so that means hopefully less to go wrong. So all I need to do is get the heatsink on there, and I'll put it back in a bit of shrink wrap, and away we'll go. So there it is. I've got the heatsink on there now, and I've got the shrink wrap around it to hold it all together. I've already programmed it and tested it before I wrapped it up, and it seemed to be working pretty good. So I guess all that's left now is just put it back into the lathe, see how it goes. So I'm just doing the calibration of the high gear at the minute. I've already completed the low gear. I've got the EC just sitting out here for the minute while I do the testing to make sure if it fries it saves me taking it apart again. But one thing that's immediately clear is that I'm getting a lot lower speed capability and higher speed capability as well, and it's also a lot more quiet. I mean, it's clearly, you know, about 100 times more quiet. So I'm pretty happy with that. So we'll measure it a bit later and have a look, but so far it's looking pretty good. Well, that's going to be about it for this episode. So what have we learned in this episode? Well, we've learned that using that combination of plastic and steel gears has actually quietened the whole thing down quite a lot. And the operation seems a lot smoother, and I'm not sure what it is, less friction or less inertia or whatever, but we are definitely seeing much ability to have slower speeds and also ability to have much faster speeds. So that's a really good outcome, I think, and I would recommend it actually. So this is what I've got left over. In fact, it's the big metal gear and the small plastic gear which I'm using. And since this is the one that was sort of wallowing around making all that galloping in that original problem I was trying to address, you know, we don't see that here at all now, so that's great. So that was a great idea that was brought up by a viewer. So viewer comments always welcome, and yeah, and I definitely take them into consideration as they come in. The other thing, which was also another user comment, was regarding to making sure I had aligned the ways and the chuck so that they were parallel with each other. And as I said to that viewer at the time, is that I actually have been checking that in the past. However, pulling it off and putting it on, you know, I obviously didn't check it properly. And not only that, historically I think it's never been really very right. So this time, by doing a more thorough check with that long rod and putting things here on the compound itself and measuring it properly, really just showed how bad it was. So I think that's one thing that you can take away, is that the alignment between the main shaft here and the ways can be way off. And if it's way off, it means it's going to really wreck up anything that you're really cutting. Even if it was 2 or 3 centimeters in length, it still would have had a notable effect. And in fact, that's where and why I'd noticed it, as I was actually cutting something a few centimeters long, and I noticed it was like you know, quite a lot out, like about 0.2 or 0.3 millimeters out. So something was seriously wrong. So I definitely recommend you go and check that if you've got one of these mini lathes, and spend some time to get it right, because it's going to make a big difference to your work as you work with the mini lathe. And obviously, again, we discovered that the ESO I'm using is terrible. As I expected, it decided to die again, and I've rebuilt it again. This time, however, I learned something new, is that the old toaster oven is as good as anything for a solder reflow, so I was able to rebuild one of those MOSFET boards pretty quickly with that toaster oven trick. And also I'm going to that single board configuration, so less parts, hopefully less chance for problems. But I don't see it getting all that hot, and I don't see any performance difference. So, and the specification, as far as amperage wise, of those MOSFETs seem to indicate that I can get away with that single board. So I think that's worked out. It's much better that way, and it's easier to maintain. If the board blows, I can easily pop that board off and plug it back in, as opposed to trying to deal with that Frankenstein monstrosity that I had. But even so, you know, in the future, I'm really thinking seriously about having to rebuild or build my own or design my own speed controller, and I really want to build on with censored base arrangement, so that we don't have to have all of this sort of jumpiness. And I probably would even go as far as to putting some sort of sensor on the gear lever here, so I can sense what gear I'm in, as opposed to using that trick that I'm using where I'm actually comparing the speed differences between the motor and the chuck. Probably beyond that, other things that are coming is that I finally bothered to order the tool holders for the quick change tool posts, which I have. As you've probably seen in a prior episode, I didn't have the correct tool holders, and I was thinking about grinding them down, but in the end I've just given up, and I've decided to bite the bullet and order. I think I ordered about 4 of them from AliExpress, which means they'll probably arrive in about 3 months. But anyway, at one point in the future, you'll see me back with the quick change tool post. And probably the final thing that I'm thinking about pretty seriously for this mini lathe is actually doing a light CNC arrangement on this mini lathe. And what that would mean is I want to have some sort of configuration where I can control the these compound controls automatically and control the speed. And so that would allow me to be able to do some sort of outer curves and a few other more complex shapes automatically. And so it would automatically control the compound and make the cut, and as it's making the cut, it would also control the speed of the chuck, so that you get a consistent surface cutting speed. So that's something I'm pretty interested in doing at some point in the future as well. But anyway, I think that wraps it up for this episode. I hope it was of some use to someone as usual. If you enjoyed the episode, then don't forget to like, subscribe, comment, or whatever you like to do. It's up to you. But anyway, I hope to see you next time, and yep, that's about it. I'll see you then.